Assalamu alaikum. Today, I would like to talk about the easy method to find the derivative of inverse functions, trigonometric function, that are inverse trigonometric function. So I have three functions here, and I wanted to show you how to find their derivatives. So when given such a function, suppose this is function theta being the function of sine inverse of x, and also theta being cos inverse of x, and theta being tan inverse of x. So let me show you how to find the derivatives of each. So solution. Let's start with the first function, which says theta equals to sine inverse of x. So we all know that the derivative of that function is supposed to be written as d theta dx. So equals to what? But looking at that function is an inverse of sine, but not sine x. So in mathematics, we don't have the direct derivative of sine inverse of x. So since we don't have the derivative of that function, therefore we can rewrite this function in this form. So shift sine inverse in the other side so that it comes back to remaining x equals to what? Sine of theta. I think we are all together up to that point. So let's differentiate now these new functions, but we have to differentiate in terms of x. So differentiating d theta in terms of x, since this is x, therefore it just remain 1. The derivative of x is 1. Since we are differentiating in terms of x, and this is x, it just become 1. Then which equals to the derivative of sine theta, since theta is not x, and we are differentiating in terms of x, therefore it will be just cos theta, but we have to write d theta dx, because we were not differentiating, we are differentiating in terms of x, and this value here is not x but theta. So we will retain the theta dx, showing that we were not differentiating x, but we are differentiating in terms of x. So we want our d theta dx now. It will be just d theta dx is just 1 over cos theta. Now changing cos theta now in terms back to x in terms of x, then we just use the Pythagoras Theorem. Pythagoras Theorem says that sine of theta is just opposite. Sine of theta, assuming this one is theta, is just the opposite which is x over hypotenuse. Hypotenuse now, this is just like x over 1, which just hypotenuse is 1. Therefore, getting the adjacent of this, just the square of hypotenuse, so it will be 1 squared, which is 1, minus x squared, which is x squared. Therefore, cos is just adjacent over hypotenuse. So just write cos theta being what? Opposite, which is root of 1 minus x squared over 1, which is remain the same. Therefore, since this one is cos, the derivative, so derivative of sine inverse of x is just 1 all over cos, which is the root of 1 minus x squared. Now, we are now done with this one. Let's go to the second derivative. So since theta is equals to cos inverse of x, therefore we can write this function in this form. X just cos of theta. Now we know that our derivative is d theta dx. But we don't have this derivative. let's find it. So meaningly, we have the new function. It was difficult for we to get the direct derivative of cos inverse of x, but when writing in this form, we can get it. Since d theta dx, we can differentiate this function in terms of d theta dx. So when you differentiate x in terms of d theta dx is just 1, because we are differentiating in terms of x in respect to x. This is x, no problem. But let's differentiate the other side. The derivative of cos x is just minus the sine of theta. Derivative of cos theta is just minus sine of theta. But let's come back to our function. Our function was differentiating, we had to differentiate in terms of in respect of x. But looking at this one, it was not x, meaning we have to retain d theta dx, meaning that we were not differentiating to show that we have differentiated in terms of x, but it's not x itself. Let's write now. Getting the theta, the s just dividing by negative sine theta, which is just the theta all over dx is just 1 all over negative sine theta. Then we were done with the second derivative. Can't you see this method is simple? So coming back to our trigonometric substitution, we said that x equals to cos theta. X equals to cos theta. But our x is here. But cos is just adjacent over hypotenuse. Now, meaning that our theta should be this one. Since this is x, then our cos theta is just adjacent. This now is our adjacent over hypotenuse. Coming back to this triangle, now we should use our theta to be this one for cos. Or we can draw our new triangle and apply this triangle to solve cos of x. So it's just adjacent. So when this one is theta, this is the adjacent and this is hypotenuse. So getting the opposite is just taking hypotenuse squared minus x squared, which is just 1 squared is 1 minus x squared. Then we are done with that. Now, what is sine of theta? Sine theta is just adjacent, opposite over hypotenuse. Sine theta just opposite over hypotenuse, which is root. So sine of theta is just root of 1 minus x squared over 1, which remains the same. Therefore, d theta dx is just 1 over negative root of this one, which is 1 minus x squared. So we can, which is the same as minus 1 over root of 1 minus x squared. And this is the derivative of sine inverse. So finally, we can find the derivative now of tangent inverse of x. So which this one we said is the function of theta. So write it in this form, which just x equals to tan theta. So differentiating tan theta is just give you what? Differentiating this one, x, just give you 1. This in terms of x, differentiating d theta dx. So in terms of x, this should just be 1. In terms of x, this is just sec squared of theta. But since you are not differentiating x, just retain the theta dx. When you retain the theta dx, then divide by, means the theta dx just 1 over sec squared. So d theta over dx just 1 over sec squared of theta. So since tan of theta is x, so draw your triangle and apply the Pythagoras theorem. Applying the Pythagoras theorem here, so assuming this is theta, then tan theta is just opposite over adjacent. Each opposite over adjacent, it will be 1 over 1. Getting the hypotenuse, just you add 1 squared plus x squared. So we have our function as that. So, but we can't use this triangle to obtain sec squared theta direct. What should we do? We know that cos we know that sec squared of theta, sec squared theta is just 1 over cos squared of theta. So sec squared of theta is just 1 over cos squared of theta. Then let's apply it. Therefore, we are just the need there is just to find cos of theta. Now cos of theta is just what? Adjacent over hypotenuse, which is 1 over the root of 1 minus x squared. That is, but we are interested with cos squared of x, which we just square this result here, which is 1 the root of 1 minus x squared. Squaring 1, we just get 1. Squaring this one, then the square. Squaring 1, we get 1. Squaring this one, we just cancel out the square with the square. Squaring this one, just cancel the square with the square root and remain 1 minus x squared. So that one is cos x squared, but we are interested now. We were to find d theta dx, which equals to 1 over sec squared of theta. Now we have cos theta, but we know that sec squared theta is just 1 over cos squared theta, and we have our cos squared theta here. So when we divide by a fraction, just multiply by the reciprocal. So we are dividing by cos theta, and cos theta is this one, and it is a fraction. We just mathematically just multiply by the reciprocal, which is just 1 over 1. We multiply by the reciprocal of this one. When we are dividing by this, just 1 minus x squared over 1. So meaning that sec squared theta is just 1 minus x squared. Think you are understanding that. So finally, we just conclude that tan inverse of x is just 1 over sec squared, and our sec squared is here. Simple. Like that. And this is the derivative of tan inverse of x. So I think you are enjoying listening to me, and if you benefit in these videos, I just ask you to subscribe so that I can also benefit to that, because there's nothing that I'm benefiting from that video, and it costs you nothing for you to subscribe. So for me also to have such a benefit, you just subscribe. It costs you nothing. So thank you very much, and welcome.